YouTube, this is Sonic2KK here, and sorry if my voice sounds a little groggy. I've just had a bit of a stuffed up nose recently and I'm kind of half recovering. And when I woke up this morning, my voice sounded a little bit strange. And my voice might sound a little bit echoey because I'm in the living room and it's a lot, it's like there's more of an echo than what there normally is. But anyway, on with the Python tutorial. This is Python tutorial, God, I'm not sure what would this be, maybe 14 or 15 for Python. And in this tutorial we're going to talk about the name variable, this little thing here, and maybe more in the init function. But yeah, you may have been browsing some Python code and you might see, like if you've been watching some tutorials, you might say if name is equal to main and then print hello world. You might not know what this does. Now, this checks if the name of the file is equal to main. Now, you might be thinking, oh well, the name isn't equal to main, it's die.py, right? Or if you remove the .py extension, you might say the name is die. So it's not main. But if we run python die.py, it prints hello world. Now you may, your mind might be blown right now and you might be like, whoa, what's going on here, Eamon? Well, what this does is this says if name is equal to main. And like I says, you might be thinking, well, the name isn't equal to main. So, how does this work? Well, whenever you run the Python file, either from the command line, the initial file that you run, aka your main file, it doesn't have to be called main in Python, and it won't make any difference if it is called main. Whenever you run it, Python makes that the main file, and it gives it, I think among other things, it gives it a name variable, and that name variable is equal to main. So the file that you execute, it gets a name variable, and it's main. So this is your main file. So the file that you execute, it doesn't matter the file name, is called main. So whenever I type python die.py becomes, it gets the name variable, and it becomes main. Now if we go into die2 over here, and import die, and say if name is equal to main, and then say print this is lols, just for no reason. In fact, Sparta. I think I spelled that right. Then we say die2, it will say this is Sparta, because this die2.py is now the file that we're executing. It is our main file. So the name variable here is not main. I don't actually know what it's called. Maybe main2 or something, I don't know. I might look that up and we might do that in the next tutorial, but basically this is not the main file anymore, and this gets this name variable here gets the variable, or it gets the name variable, and it's main. Its name is main because it gets the value of underscore main underscore. And why is it underscore main underscore? I think it's because the Python creator doesn't want to conflict as much with built-in names. This is basically because if they called it just name, then it might conflict with other names that you have created. And yeah, hopefully that makes sense. So yeah, the file that you run gets a name variable. Well, every file, whenever it's compiled and ran, it turns into I think it turns into Python bytecode, which turns into C code, which then turns into assembler code, which turns into binary, which the processor reads, and yeah, which I think I'll talk about in a second. Or yeah, I might talk about that in a second. So if name is equal to main, if it's the main file that we're running and the name variable has the value of main, then print this. But since we're running die2.py, the name variable is getting the value of main, and then it says this is Sparta. Now why is this underscore main? Probably just to keep with tradition. Because this is underscore, just make it look nice. Yeah, so also what I want to talk about is the layers of abstraction. Now basically, what does that mean? Now, in simple terms, it's how simple a language is basically. But let me get deeper into that now. You know how Python is really, really simple to use? How it's one of the easiest languages, and if in case you didn't know, there's a lot of kids that are using it. Like I go to this code class. Well, it's like a mini code class, and they teach Game Maker, which annoys me. But anyway, they have Raspberry Pis, and they're teaching kids how to program Minecraft Pi Edition with Python. Now, you couldn't teach C to a kid. You know, it would just be, well, I know C, but I learned it myself. But you couldn't go into a class and say to a bunch of 9-year-olds, right, here's C, and this is all about memory management. You have to know how to allocate and deallocate your memory. You have to know about pointers and how to optimize your program. Wow, my phone just went off. How to optimize your programs and all that fun stuff. You don't want to try and teach that to a kid whenever they're learning programming. And there's my iPad going off. And my phone just went off. Now I'm waiting on my laptop going off. Anyway, so Python is really easy because it is highly abstracted, which means you don't have to worry about memory management. You don't have to worry about memory. You don't have to worry about pointers. You don't have to. It's basically the farther away from the metal you are. I think somebody described it. Think of it like a car. The majority of the people that drive a car don't know how a car works. They just know press the pedal or the gas button, and it'll make the car go. Turn the wheel to make it move, and the basic stuff. They only know the basics. They don't need to worry about how the engine works. They don't really want to know about like how the engine takes the fuel and all that stuff. They don't want to worry about all the low level stuff. They want to just get a car and start driving. They don't want to actually learn how the car works, and that's kind of what abstraction is. So in Python, you can think of it as this. So there's Python. So Python, the language itself. And then below that there is Python bytecode. And then that is basically what whenever you run Python, it gets turned into bytecode, which is like code the Python interpreter reads. And then it turns it into, I think, I'm not exactly sure what it is, but let's just say for the sake of example, it's C. It turns into C code. And then it gets turned into assembly code. Now, if you don't know what assembly code is, you don't have to worry about it, because I don't think you really want to know. But as a basic example, and feel free in the comments, any techie people to correct me, basically, it turns into assembler code, which assembles it into binary. And then the next level is binary, which is what the processor reads, and that is it. So Python bytecode, C, or whatever it gets turned into, assembly code, and binary. It's like this in Java, it's Java bytecode, and then assembly code. This is how it works in Java. It goes to Java, and then Java bytecode, which is what the JVM reads. That turns it into C, and then turns into assembly code, and then binary. But with C and C++, I don't even think it needs to go to the assembler. I think it goes straight into binary, and that's why C and C++ are very low level. And I think Objective-C was for a while, but I think now you don't have to worry about memory management, allocation, deallocation, Objective-C and Xcode and all. iOS, they all do that for you, so you don't need to worry about that. And with Java, you don't really need to worry about it as much. So that's just a little bit on Python abstraction and how Python actually works, and the name, So hopefully you learned something in this tutorial. Thank you for watching, and I will see you in the next tutorial.